Hello everyone, this is our uh, final project, Golf Coach Milestone 1, and my name is Mingjing Huang, and here are my teammates.
I'm Faye.
This is Zhipeng.
Okay, now we know that our project is uh, an advanced reinforcement learning based system designed to help users to improve their swings through AI analysis, and users can upload swing videos, receive automated feedback, and track progress over time. And I am responsible for the front end of the system. So this milestone focus on building the base UI and implementing the video upload and the preview. So now we use Android Studio and Kotlin and Jetpack Compose to build this system. And we achieved the upload and preview section. To uh, to prove that the application can compile and run successfully on the emulator. Now we can see this is the app, and the implemented features is we integrated Android's photo picker and open document. So users can select swing videos from the system gallery or file manager. And we added Media 3 for local video playback and displayed file name and size after selection. And this is the main activity. The Golf Coach upload and preview. This is the main compose screen, and we can pick up our file from Picker 13, videos only mode. And then is the video player. So we can select the video from the file, but I didn't upload any video, so we can see it. I think we should like link the backend to see this video. And after that, we can play this video and get the file name. And future extension
to authenticate ourselves first. So the username is user1 and password is 1234. We just authorize, so it will choose that successfully log in and authenticate ourselves. So now I will act as this user and upload a video. I'll call Paul API upload endpoint, attaching the token for awesome and for video. I just randomly attached a file and run it. So look at this response. We instantly get a video ID and the ID is 3 and the status is pending. The API is fast because it's not doing the processing itself. It has successfully uploaded to S3 and created the job. So right now, our salary worker is processing this job in the background. For this demo, I will set the simulated 5 seconds of the work. So if we check here, get API status video ID, we will get completed. So as you can see, it shows here, the worker has finished its job and uploaded the database. So finally, since the job is completed, we can fetch the file result from get API feedback. So also here also we enter our video ID, which is 3, and run it. So it will choose it's our placeholder feedback. It's confirmed that API database and worker are all communicated correctly. The entire round trip is successful. The text is just the random name. It will in the future we will give it as a real feedback from the ML model. So to summarize our milestone one, but in the background, I have successfully built a secure token-based user authentication system, a robust asynchronous architecture for processing large tasks, a complete end-to-end data point pipeline from video upload to feedback retrieval. So the backend now is fully prepared. The next step is to integrate the real ML interface model from Service C. Service C, we will replace the placeholder function, which shows here. We will replace it, the placeholder function in the future with the actual model call, and the system will able to provide the intelligent feedback. Okay, thank you. That's all for the backend.
Yep.
I'll pass it to my teammate.
Okay, I'm going to share my screen. So I'm responsible for the ML parts, which is the reinforcement learning. So at this stage, I'm still doing the data acquisition and motion segmentation. So this is the foundation for all the subsequent reinforcement learning components. And the current system, like you can automatically extract post key points from raw golf swing videos, which would very clean and stabilize the motion data, and we can accurately segment the swing into key biomechanism phases. Uh, this milestone represents the completion of stage A, which is the data and the phase foundation. I'm going to walk through my code and to have some output for the demonstration. So we have the first of all, the post IO. So it's for the post extraction and the time series processing. So we use the media pipe pulse to detect 33 human body landmarks from each frame, and with parameters turned for the high-speed video sequence, as you guys can see from um let me from here. Yes. So each frame provides normalized coordination XYZ, and they belong to the range from 0 to 1 for all the landmarks, which are rescaled into pixel coordinates using the frame width multiplied by the height. And from this, we retain only the relevant biomechanisms joint for screen analyst, like the height, the top are the scalar landmark, and the shoulders, left, right shoulder centers, and the hips, and the elbows, and the hands. So these points are sufficient to reconstruct the uh, main train for the upper body and measures the rotational and the translations motion. And And this is when we run this code, it will output CSV files. But for the demonstration, also write a video one. So for this one, we can um, clearly see it. Let me run this. So you guys can see there's yellow line and green line and gray line that represent the golf player's arm. And there's some um, this is the demonstration that we extra extract the main point from the bodies. So and then um we and I want to mention the very important part, which is the forward field theory. So this one is to handling the missing frame. So in practice, like the media path may fail to detect a body part for a sentence frame, like for example, like due to the partial occlusion or like motion blur. And so to maintain the temporal consistency, we implemented a forward field mechanisms called SWAN that replace missing the value now with the most recent valid observation. So we will ensure the continuity of the position data across frames and prevent numerical errors in velocity and the distance computation. And also, we preserve the like short-term temporal coherence, especially important for the print frame velocities, and for functions like a handle hip distance. And a year later, the reinforcement learning stage, it will avoid like false speakings in the reward function due to like job detection. So and also, so even with like the forward filling, the frame post data will still contain jitters. So we applied like the EMA, as you can see, it's called the EMA smoothers. So the stand by the exponential moving average smoothing filter. So it's uh to each checker joint. Well, so this will reduce like the frame to frame noise while preventing the dynamic motion. So we can imagine like the line will move like a curvely, not like the up down, like have the edge in that lines. So it's more like the sine line or like cosine lines. So like DMA is preferable to a simple moving average because it introduces like a minimum latency and avoid the over smoothing sharp transitions. And then we have the segment PY. So this version fire can help us determine the swing phase using only the late hand vertical position, which often like means classify frame in the follow through at the top. So we know like in the golf, the swing can divide to two events, the the top and the pre-impact and the impact and the follow through. So we replace the this with multi-Q, which is called constraint-based algorithm that consider temporal derivative with local extrema and interjoint relationship. So um, we detect the top of the backswing with the local minimum of hand height and the sign change of the vertical velocity with a low hand speed and must occur after backswing start. As you guys can see, we have a phase segment debug file here. So this file can help us clearly see what I'm doing right now. So I'm going to running. There are some help function help me to do it. And similar here, we use the media pipe. We have the post object, and we extract the post and make them to be a series. So we here we have like the left west series or right west here series, and also have the left elbow series. So as you can see, I output to CVS, we have all the 2D coordination of the golf players. And then we have like I was doing debugging here, so we want to find the accurate top position. So it's called top, find the top. And you can see we use the 114 and MP4. So this is output. The top is at the 126 frames. So let me output the 126 frames. Yeah, and you guys can see the head is on the top. So it's and also let me verify the other data about so we are only implement the players face to the cameras. We still want to add like the when the camera is back in the player. So this view we cannot handling. So we don't have the corresponding code. And then we have the 9, which is 9. So they have the two video look like similar, but the second one is has more frame than the previous one. So we use the slow frame one. So okay, so it shows 148. So as you can see, the top the position is at the top one. So and then when after we dealing with the top position, we should also need to handle the impact and the also the pre-impact when the line is parallel with the ground. So and So the key design element in this file, which is the backswing start detection. So it will identify the first interval where the hand height raise motioning with the increasing speed, and then we should have the each phase should find with the boundary frame window to represent out of the phase action mark. And then we have some minimum frame gap where to enforce like a realistic separation between the top and the impact. And also during the reinforcement learning, we have some like the multi-cue scoring, like we have some weights to different position and some like the fallback logic. And also, they have some others like called features PY. It's also preparation for the reinforced learning. It will calculate the angle between different parts, and when we add the weight, then the agent will know which part is more important to help the player to swing a higher score. Also, we have uh, the ROM PY. So this one is the integration pipeline. So it orchestrates the end-to-end workflow. So it will handle like the post extraction via the post IO.py file will produce and a smooth join sequence. And we have the phase detection and some features computation. So all the results will save in the JSON with the phase index. And also we have the CSV file for the training to the agent. Um, I think that's the milestone one for the RL. So we have implemented like trying to implement like a reliable media pipe based post extraction. So we want to close entire swing sequence. And also we want to do the continuous time series reconstruction um, uh, using the series. And I want to get the robust space segmentation to the algorithms. And for the next milestone, we will do the reward engineering. So we will since we have already calculated the normalized angular and the linear matrix. So then we will scale all the features like relative to the body height and or shoulders width to ensure that the player independent comparability. And then we want to design our reward function. We'll define like the ideal biomechanisms target preface like this stable height or like a proper hip rotation. And also and to cite like the reward weight that reflecting the coach priorities and to implement some function like a computer like reward for quantitative scoring and also to prepare like the environment for the golf advice for the like reinforcement learning and which and I also have some like we will put the fixed futures with context at the observation. Then we also need to prepare like the specific some advice type set is for the action as the action for the agent, and then it will compute like a performance score. Then we'll jump like the future step like the base times three or any else. So for now let me have a summary. So we have still doing the data preparation and the phase segment pipeline. So we already have a stable 2D pulse line series, like a representative of each golf swing. So and we want to build so far we still want to build a very robust method to detect the top per impact and the impact frames. And that's all. Thank you for your listening.
Okay, thank you.